Thank you very much, Scott. Very, very pleased to be here today working with the LAS on the High Bay Initiative. Again, my name is Steve Duff. I work with Conrad Lighting Solutions for the LAS initiative, and I am a lighting designer. And what we do is we design and optimize a lighting system to produce lighting levels that are appropriate for the task at hand. And when we design light levels for the task at hand, we look at the lighting level requirements, where those lighting levels may be either on the ground or at a certain height or on a vertical surface. And we determine if it's going to meet the needs for safety and enjoyment that have to be considered for the task at hand, and meet stringent requirements and ensure that they are met by producing simulations ahead of time. When we look at standards for lighting, there are a lot of different standards, but one of the most common references is the standards and recommended standards for minimum luminance levels from the Illuminating Engineering Society. And the Illuminating Engineering Society produces documentation that has recommendations for all sorts of different applications. It could be an arena, it could be an office space, it could be a mine. There are virtually thousands of different spaces that the Illuminating Engineering Society, or IES, has conducted studies to determine what the appropriate recommended levels are. In our case, we work with you folks on a number of different facilities, as Scott talked about, fire halls, it could be pools, but we're really going to concentrate today on sport and for hockey. And when we look at sport, we have to see if it's an aerial or ground level type application. We look at the class of play and the facility. What is the type of play, the level of play, the size of the facility, and the number of spectators. We look at the horizontal illuminance requirements, and we'll talk about illuminance, and vertical illuminance, and uniformity requirements, light distribution. That's very important, and we're going to be getting into that quite a bit because some applications, the uniformity, the dark spots and light spots of the light produced are not as critical as other applications, and certainly in sport, this is critical. So, like we said, for the discussion, we're going to review the process for hockey, and basically what we are doing is we are determining a luminance that is falling on the horizontal target, which is where the players are playing, and also the vertical targets. How are we seeing the players? How are we seeing the net? How are we seeing the board? And then we'll talk further about how do we see the entire room. We'll talk about that later on. In photometry, illuminance is the total luminous flux incident on a surface per unit area. It is a measure of how much the incident light illuminates the surface, wavelength weighted by the luminosity function to correlate with human brightness perception. What that essentially means is the amount of light falling on a given area, and that's what we calculate. So in ice hockey, maintained illuminance targets, foot candles or lux, is the average in a given space. So we're going to talk about maintained luminance a little later, but in a nutshell is we're not looking at the light that is installed and what the levels are immediately. We're looking at light later on in the operating cycle. It could be 10,000 hours, 20,000 hours, 50,000 hours, but the light that you install, what is the light that is giving you after time? Because we need to meet these levels over time, not just immediately, so that we can meet the requirements of play. So class of play, we have different levels. We have leagues, clubs, semi-pro, professional, and the IES recommends foot candle values, and this is what we're showing here, foot candle values, not lux, of the space for the different classes of play. So the baseline for leagues, which is very common for facilities in North America, would be an average of 50 foot candles over the space. clubs, semi-pro can get up to 75 to 100. Professional NHL level type play requires a target of 150-foot candles, and that would be for the audience, the distance of the spectator, and certainly television. And we can certainly work with a facility to determine what your class of play is. You know, we've gone to visit a lot of arenas. Some arenas have a baseline of class of play. Some arenas have television Rogers that are involved, and we may want to look at the lighting levels to account for that. And then here we talk about gauge, which is average. So we're going to get into what average really means in a little bit. So in reviewing photometry, we look at many factors, and some of them we're going to review today. There are virtually thousands of factors that we do review when we're designing a lighting system, but we are reviewing a class of play, which we talk about, average foot candles on a surface, maintain lumens or light output, building a photometric model, uniformity and proper light distribution, room reflectances, and room geometry. So, average foot candles. So have a look at this chart. We'll spend 10 seconds to let everybody take it in. This is a plan view of a simulation of an ice rink and a room that surrounds the ice rink. This room, we could say, is let's say 30 feet high with a particular shape. It really doesn't matter at this point what we're really looking at in terms of specific geometry. We're just trying to show an example. We have done this on photometric software, and with the lighting system that is proposed here, 18 fixtures, we are showing foot candle values on a grid, which is in this case a 14 by 14 foot grid, and within the space, the hockey surface area, and this is what we're measuring. Don't look at the values outside of the rink. Okay, we'll look at the values inside the rink because that's the area that we're measuring. We have values that range anywhere from 36.7 foot candles all the way up to 65.6 foot candles on the grid. And this gives us a 50-foot candle average over that ice surface. This is what we've measured. And the uniformity ratio between the higher and lower values is measured at 1.79. For this application, we usually try to target less than 2. Like I said before, in other applications, we might be accepting of a higher value. In the case of hockey, we target less than 2, and the smaller the number, the better the uniformity is. So here you see the ice rink. Please ignore the top line foot candle values because it's actually hitting the boards and it's skewed incorrectly, but on the ice surface, underneath one fixture you have 65 foot candles. Under another fixture you have 36 foot candles. So if you measure under one point, 65 foot candles, it doesn't mean that you have a 50-foot candle average that is recommended by the IES. So if someone is working with you and you're measuring one point to say, hey, I've got you 60-foot candles here, you need to ask, but what is my average over the entire rink? This is what we're designing to. This is why we look at the number of the fixtures, the increased number of placements, the place that we're putting the fixtures amongst multiple fixtures to produce this value. Because if you look at this next chart, here we have measured points underneath the center fixtures. That gives you 58-foot candles. Okay? But if you look at the average of this particular system in this room that we created, it's only giving you 47.9 foot candles. So you just need to think about that when you're looking and comparing systems. Another subject that we talked about was maintain lumens or light output over time. So when we design to target 50-foot candles average, we design over time. So we don't look at the lighting system and what it's going to produce when it's installed at the get-go. We look at it over time, depending on the system that we're using, and bring in factors to calculate how the original lighting will deteriorate and target to that deteriorated value. And what factors are we looking at? Dirt depreciation, the efficiency of the system, the lamp or LED depreciation. Lamps, LEDs, sometimes people say they're like rock stars. They never die, they just fade away. And that's the case with LED systems. And some systems deteriorate more rapidly than others. So as an example, metal halide system, your HID system, after 20,000 hours, you could have deterioration up to 50% of the original light value. And that's what you need to design to. And when we design and we look at a simulation of your current system, we're not looking at the light levels that you get when you first put the lamps in. We look at the light levels that you're going to get at 10, 15, 20,000 hours. And that's the value that we're looking at as a reasonable maintained lumen value for the system. So a high-grade LED system, which we love, we can look at 95% of the initial lumens of the LED after, let's say, 60,000 hours to reach our 50-foot candles. For a typical LED system, you might design to 85% or even less. It could be 70%. If you had a very, very low grade fixture, you might be looking at even less than 70%. So you have to be very, very careful when you're looking at the system and what you're actually designing to. That little box in the lower right-hand corner comes from the photometry software that we use that looks at all the different factors that we look at when we're looking at the light loss factor, again, from dirt to the ballast factor to a number of different measurements to give us a real value of what to measure to. So how do we do it? You know, we appreciate the questionnaires that we have received already, and with that questionnaire, there's a lot of information that is provided, and we use that information for preliminary photometry that we conduct without even necessarily coming to your arena, which we don't have that, but we have important information. We have your rink dimensions, we have your existing fixture heights, the fixture types, your rink size, your ceiling height, and we appreciate the photos and drawings that you might have, and other information is provided to give us not just a visualization, but some metric values that we can start incorporating into a photometric model. So we use specialized photometry software that we input this information into. And with that software, we start looking at different LED fixtures that might be appropriate for your space. If you have so many fixture placements, we might start looking at a particular fixture that we think might meet that requirement for your space, you know, to go after that baseline average foot candle value for your space. And each fixture, quality fixtures, has something called an IES file, a .IES file. And what that is from quality manufacturers to simulate lighting in a space and provide calculated values for the fixture. The fixture itself is measured on a device that you can see in the center screenshot, the lower right-hand corner, a gonio-photometer, which essentially places a fixture and takes measured values in a spherical rotation pattern to then create a file that will give you values around different points of the actual fixture. These fixture measurements are conducted by third-party equipment, independent of the manufacturer in most cases. So from these files, we then computer model a room that we model a computer space that shows the height, the width of the room, the rink size, and then we start placing IES file supported fixtures into that particular room at the given height where the fixture is going to be. We then look at reflectivities of the room, and we use a default here because we have to have a standard. We'll talk about reflectivities, but we use a default of 60% for the rink, 30% for the walls, and a higher value for the ceiling because a lot of times the ceilings have a reflective surface on it, so we use that value. And with photometry software with fixed or photometric values placed in that simulated room, it allows us to estimate the approximate light levels in an area of reference. So, for example, we simulate light levels with a typical HID fixture that you may have in your facility. We have a number of IES files on file that allows us to do that, and we take up to a 50% light loss factor to determine what your current lighting system is giving you. Yes, you may have changed out your lamps 2 months ago, and yes, your lighting values may be significantly higher, but for the purposes of photometry and what your class of play lighting actually is, you've got to look deeper into the life cycle of the lamp. And then we simulate our proposed quality grade LED fixture as an example, the IES file that may have a 95% light loss factor or a different factor depending on the fixture that we are looking at. For the new fixture, we target minimum 50 foot candles average or more depending on class of play. And here you can see that even now, before even seeing your space, we can start building some simulations of what the lighting will look like in a render mode, and we can get calculations on that point-by-point grid over the surface area of the ice that we talked about before. So we talked about as well about uniformity. Uniformity targets are key for demanding visual tasks such as hockey, swimming, and maintenance areas. So here we have 3 different designs to show you an example. On the left, we have 18,000 watt metal halide lamps. In the center, we have 18 narrow distribution LED fixtures with no lens. And these lower grade fixtures have an L70 lumen maintenance. So again, over let's say 50,000 hours, it might have 70% of its original light output from the fixture. And then on the right hand, we have 18 wide distribution LED system fixtures with a lens L95. So let's look at the values below. On the HID metal halide system on the left, we get average foot candles, in this case 60.55 at L50. It could be anything. This is just what we simulated. We have a min-max of 43 to 72 foot candles, which is a uniformity of 1.4. That's pretty good. You know, there's no reason why you can't have a good uniform HID system, especially when you have more placements. And the wattage is 19 kilowatts, quite high to operate your system. Here in the middle, we look at a narrow distribution LED system with no lens. Those different colors represent different foot candle values in the space. And here we have 65 foot candles, but I'm going to rub this in at L70. We're only going to have 46.6 foot candles. Our uniformity is not as good. We're ranging anywhere from 32 to 62 foot candles. Our wattage consumption, though, is very, very good at 7 kilowatts. With a higher grade LED system on the right, where we are using a lensing system, and we're using a wider throw, we have our foot candles at L95 of 54.51. Look at the uniformity ratio, 1.33, fantastic, 41 to 69.4. Very even ice surface. It is also lighting the outside walls of the arena space nicely. It's not as much of a cave when you do that. The center ice that we're looking at, you know, I don't like to use the word cave, but that's sometimes how people refer to it, is that it's a cave effect. And in the case of the wire distribution, the aisles are lit up nicer, more even distribution. And while the water savings in this case is not as great, you're still saving a significant amount of wattage, and you have much more satisfied customers at the end of the day. So you got to be very careful when you're looking at different fixtures. If you're not using correct optics on the fixture, you can increase your shadowing on the surface. You can have dark and bright contrasting areas on the ice. When you have poor uniformity on the ice, a lot of light and dark, it can increase fatigue for players. And also for spectators, when they're looking at the sport, they can experience increased fatigue. And when you don't have good optics and lensing on your fixtures, when you look up at the fixture, it can increase the potential for retinal burn, essentially an after image. And those contrasts can certainly be amplified under video and television. So some other things that we want to consider in photometry in our design. We've laid out the different fixtures in our room, and you know, this is where we really need to eventually get into your facility and really look at the attributes of the space. You know, the room cavity is critical. So if you look at the top line on the left-hand side, here we have a space, okay, equal width and length, that has a ceiling that is flat over the fixture placements that are at a particular height. So with the flat ceiling, with the light coming down, even though it's coming down, that light's bouncing all over the place, okay? And then it eventually hits the ceiling, and that ceiling is closer to the ice surface than another design, and then that also lends itself to the light on the surface play area. So let's say we take that same system, and with it we put over it a vaulted ceiling. Okay, so that light now that's reflected off the ice surface going back up to the ceiling has further to travel to then come back down to the ice. And what happens when you have that vaulted ceiling? You have a lower foot candle average. And in this particular case, with the same fixture, left screen to right screen, with just a vaulted ceiling, in this case, our simulation gave us 10 less foot candles. Okay, so it's something to consider when you're designing your space. And then reflectivity. We talked about, you know, paint on the walls. We talked about, you know, the ice surface. We talked about some ceilings use a reflective mesh, some do not. Those values, 80, 60, 50, look at the lower left-hand side. That's your reflectivity values for the wall, ceiling, and ice surface or floor surface. And that gives you a 54.51 foot candle average in this simulation. Same fixtures and same room geometry, same everything, but different colors. Here we simulated, you know, very high reflective surfaces of 80, 80, 80 throughout. And look at what that does to the foot candle average for your space. So here we talked about what we can do just from a questionnaire and some photos and drawings that were provided. When we're able to work with you to work out an arrangement to come and visit your site, there's a lot more information that we look at to fine-tune the results in the design that we're looking at. We measure the room and record approximate dimensions, the shapes of major objects such as beams and the seating area. We look at the height of the installed luminaires to be replaced. We determine if adjustments are required and can be made. If we can get the fixture a little bit lower without upsetting the view of the spectators, we'll look at that to increase the energy saving potential of space. We look at surfaces, paint colors that determine approximate reflectivity, and we then create a more detailed photometry model of a proposed new system. In the upper right hand, that picture, that's actually a model that we created for Mapleton, which is the case study that we're going to briefly discuss today. And you know, what's most important here is that we discuss with you your current light levels and discuss the age of the current system, discuss the appropriateness of current and proposed light levels compared to IES recommended practice for the class of play, and what your needs are. Maybe you want to have a system that meets the class of play, but you may want to be at a higher level than that. You may want to be, we may have an HID system that was a brand new relamp system that had light levels of, let's say, 65-foot candles. You don't need that for your class of play, but you may like that. Your spectators may like that. That's maybe something that you want. We then can talk to you about designing a lighting system that can work to estimate to bring you to those values. So when you're looking at having a new lighting system proposed, there's a number of questions that you may want to ask. So what is the average foot candles over the ice surface? Not what are the foot candles under this one center fixture, what's it giving me? What is the expected uniformity ratio over the entire surface? You know, am I going to have hot spots that are higher than I would not want to have? Will my fixture have lensing to improve uniformity and help mitigate glare? Has the proposed new lighting system accounted for light depreciation factors over time? Has what's been proposed what you get out of the box, or you know, after 10, 20,000 hours? Has a lighting system been designed for our class of play and our task at hand? You know, like we said, if you're in a hockey rink, it's one level of light. If you have a maintenance bay for your trucks, it may be a different level of light that you're looking at. Does the fixture proposed have an IES file in order to conduct proper computer designs and ensure that manufacturer claims are verifiable? You know, a lot of very good manufacturers in the market, and they have excellent specification sheets, but we want to verify that with proper photometry from a third party. So that is photometry, and photometry and lighting design goes in hand with the strategy of having the most efficient and energy efficient lighting system that's appropriate for your task, and at the same time be quality light and keep the spectators and players happy. So what else do we look in our assessment when we sit down and look at what your needs are? We look at the hours of operation, how many hours of lighting is in use, what is your cost for energy, cost of energy over time, peak periods, etc. We look at the switching of fixtures, you know, the accessing of switching, and you know, one great advantage with LED is the instant on-off design of the fixtures with controls, where if you have a special event, then you can turn them off when need be, and you can also dim with certain controls. And the next webinar will get very deep in controls and the next webinar we'll be talking about dimming and wireless dimming. And with LEDs, it's amazing what can be done. And you know, with controls, there is further energy savings to definitely be had. And another factor that we all need to look at when we're assessing to have a quality LED manufacturer, it's the product and the warranty that supports the product. And you have to look at the different levels of warranty that is being supported. The levels of warranty looks at the LED modules, it looks at the LED driver, it looks at the body itself, and these can sometimes be treated as separate elements of the warranty. You know, and with the different elements of the warranty, you look at the lifetime of all those elements, you know, you got to look at that, and we definitely want you to understand that warranty. And ultimately, you need to understand who has ownership of the warranty. Is it the manufacturer? And a lot of times it is. And with that, you know, you have to look at how long that manufacturer has been in business. Are they going to be around for the long term to support the product? And does the owner have a warranty with an established presence in the Canadian market to support that warranty?
So we're just going to jump right into the case study in the interest of time. And thanks, Steve. I'll throw it over to you to walk through the Mapleton case study again.
Okay. Yeah, we'll briefly look at Mapleton. You know, they had an existing system with 18 fixture placements with a mixture of HID and some fluorescent, 2,000 hours of operation, 47 volt system with a mounting height of 22 feet. And we estimated that their model light levels were somewhere, sorry, we modeled the light levels at 50 to 55 foot candles. And the challenge was, in this particular case, is that when we went in there, the existing metal halide fixtures were newly relamped at the start of the previous season. So the light levels were higher than what we had actually modeled. So which means that they got an existing light level that they had there now at 60 to 65 foot candles, and we modeled for a lesser value because we accounted for the depreciation of the actual lamp. And we confirmed the height at 22 feet. So what we had proposed originally was a model of 50 to 55 foot candles, but the management wanted to have a light level that the players and the spectators and the management wanted to have, which was the fresh relamp level in that space. So what we did, what Conrad Lighting Solutions did, was provided the customer, based on being able to do an investment grade audit, was to provide 4 different scenarios that we actually modeled for the customer. I won't get into the specifics, but we have different paybacks, but the paybacks with less fixtures was 3.75 years, and that was producing a light level of 50 or 55 foot candles with an LED system. The customer decided to look at a 24 fixture system, longer payback, but they have higher foot candles and improved uniformity. So the customer looked at the quality of light, still a very, very good payback, still very, very good energy savings. And these paybacks are, like we said before, not looking at today, but what the light levels are for the long term. So we went from 18 to 24, 48,000 lumen fixtures. We had installed a lighting controller dimming system to allow for switching and further energy savings. So when they don't have hockey and have, let's say, recreational skating, that can be dimmed down, and they will realize improved savings. And we went in there after the fact, you know, we worked a design to target 65-foot candles, and with our 37 different meter reading points on the ice, we achieved an actual light level average of 65. So we were very, very close. You know, lighting design, we put in as many factors as possible. You could put in thousands of factors as an approximation, but we worked to get very, very, very close. And I think the pictures give a thousand words in this case, and we're very, very proud of this installation. You know, again, the HID system on the left, you know, was a good system with half decent uniformity. The LED system has excellent uniformity, and the one thing that's going to be nice for these folks is that they're going to enjoy that level of lighting for a very long time. We'd like to thank Acuity for the professional photos that they arranged to have taken. They came to a visit at Mapleton. They were delighted. We were delighted. LAS was, but most importantly, the customer was delighted. And this is our goal at the end of the day. So for my part, to finalize things, just two thoughts. You must design your lighting system for the future, not for today. You should design your system for your class of play. So for my part, I'd like to thank you very much, and I'll hand it back over to Scott.
Thank